I'm Anil Kumar, and now let us continue with our example of snowball. We are reviewing rates of change. The question here is, as a large snowball melts, its size changes. The volume V in cubic centimeters is given by the equation V equals to 4 by 3 pi r cube, where r is the radius in centimeters and r belongs to the set of real numbers from 0 to 30. Part B is determine instantaneous rate of change of the volume when the radius is 20 centimeter using preceding and following interval methods. Use only whole numbers closest to 20 centimeter. Now in part A we found the average rate of change. Now we will see how to find instantaneous rate of change. In this example I only want to tell you how to use preceding and following intervals methods, right? So these are the two interval methods which are to be used to find instantaneous rate of change of volume. Normally we take 0.1 or 0.01 as the difference in the values, but in this question specifically it has been mentioned use only whole numbers closest to 20 centimeters. So what you need to do is you need to calculate the volume when the radius is 21. So following is afterwards, so find that using the formula, that is 4 by 3 pi r becomes 21, so it is 21 cube. Calculate the value of the volume for radius of 20, which will be 4 by 3 pi 20 cube, and also find the value of volume with radius of 19, so which is 4 by 3 pi 19 cube, correct? So once you have these values, then the preceding interval method will give you, let me write instantaneous rate of change as instantaneous rate of change this, and let me write preceding P. That means before 20, right? So 19 to 20. So you can say V of 20 minus V of 19 divided by V of 20 minus 19, correct? So that will give you instantaneous rate of change preceding, right, just before 20 centimeter. Similarly, you can also calculate instantaneous rate of change for following, right? So let me call this as F. So that is after 20. So volume when the radius was 20 minus volume when the radius is 20. This one is 21. Divided by 21 minus 20. Once you have calculated these values using your calculator, then you can find the instantaneous rate of change at 20 by getting the average value of these two, right? So the answer will then be, so you have to do all these calculations. I'm not doing it here. Now your answer will be, in this particular case, you will write instantaneous rate of change at 20 when radius is 20 as equals to average of these two, right? That means instantaneous rate of change preceding plus instantaneous rate of change for following divided by 2. So that value is going to give you the answer. Approximately the answer will be around 5282. Don't forget to include the units. Units in this case are volume is centimeter cube, right? Centimeter cube divided by centimeter, right? So that should be approximately your answer. So the whole idea is to understand how to use preceding and following method to find instantaneous rate of change at a point, right? So whenever we are discussing a point, we are taking two values which are very close, right? So when we say preceding and following, they should be equidistant from the average value 20 in this case on both sides. Since it is whole numbers, we took one unit towards the left and one unit towards the right to find the instantaneous rate of change at r equals to 20. I hope that helps you to understand the method. Let's continue, and in the next video we will learn how to find instantaneous rate of change using difference quotient method. Thank you.